Hello everyone, welcome back to iTeLearn. This is Karthik, and we're back to the Android security testing with Nikhil. We had a couple of sessions earlier. Nikhil was walking us through the entire architecture, the process, and the curriculum of the training itself. I think we're going to go deeper, and one of the expectations that we begin as trainers at iTeLearn team is that we assume that the audience has almost zero knowledge on what we're teaching. So we want to take the baby steps, make things look very simple at the beginning, take a project based approach rather than a PowerPoint, and slowly build on what we're doing. So eventually, in these 15-20 sessions, you would get a great hands on through it. And while we are doing these sessions, Nikhil and I, we will also keep guiding you that the importance of practicing in parallel. So in our session that you see, maybe a couple of hours of practice at the same time will make things great. Also, do note all the sessions do get recorded and will be hosted on iTeLearn.com. So if you missed a session or if you want to replay it for your review, you can sign up to your membership portal and start accessing it. That's it from my end, and I'll let Nikhil continue. Thank you, Nikhil. Please go ahead now.
Sure.
All yours.
Yeah, thanks a lot. Okay, hey everyone, let's get started then. So just a small quick recap on what we did yesterday. So we looked at bunch of things such as the architecture, and we also looked into the different layers of architecture. We looked at different versions. What is an executable Dalvik executable files, and we also tried bunch of hands-on things while we were learning all of these. We also looked at the Android security model, mainly into application sandboxing, and how the security gets implemented at the OS level. Okay, but today we'll completely keep aside the presentation part. We'll actually get our hands dirty into sort of trying and see which are the different set of vulnerabilities that we can find. Okay, for before we get started with actually finding the vulnerabilities, there are a bunch of things that we need to sort of really do. We need to really understand how we are able to sort of reverse engineer an Android application. Okay, so to reverse engineer an application, we are going to be using bunch of tools, such as, let's write it down here. The tools for, okay, so you guys are able to see the screen. Okay, so the tools for reverse engineering are, we are going to be using a tool called as APK tool, which is fairly easy to use kind of tool. Okay, so we'll see how this is used. We are going to use something called as dex to jar. Okay, then we are going to use something called as JDGUI. Okay, so these three are like one of the very basic tools that we'll be using today. Okay, and see how we could be able to reverse engineer it. Okay, so let me just minimize this. So in the Android security training folder, we have this diva beta.apk. This diva beta is an open source apk file. More about it we'll get to know in a couple of minutes. Let's copy this and paste it onto our desktop. Okay, so what I'm going to do is I'm going to right click it and I'm going to go ahead and rename it. So instead of the APK file, so one thing we need to remember here is that all the APK files are nothing but zipped files. Okay, so I'm going to convert this, I'm going to change it into .zip file. What I'm going to do is I'm going to basically extract it. Okay, so once this gets extracted, so we could close this, we could, okay, so we have the folder that comes up here. So you will get to see that there are a lot of okay, let me sort of make this big. Okay, so we get to see that there are a lot of different set of files. There is classes.dex files, then there is something called as the library files, there is something called meta-inf folder, resources, and bunch of other different files like Android manifest.xml. So if you could remember yesterday, we were talking about something called Android manifest.xml file, which is really necessary and important for any security guy to sort of know about it. So let's look into let's right click onto this and open it with any text editor. Okay, because since it is a basic XML file, it should open up in any any text editor. Okay, but if we open this up here, you will see like all these values that we are not able to understand. It's completely hex coded, in a hex format. Okay, so we won't be able to understand anything, right? So this is totally different from what we saw yesterday when we used the Android manifest viewer file, viewer application, right? So does that mean that we are going in the right direction? We may get confused a little bit here. Then again, another question might arise. Since you were telling me about reverse engineering an application, since we already reverse engineered it, why do we need these tools, right? So one thing we need to notice here is that when we reverse engineer it in a normal way, wherein converting it from a APK file to .zip file, what really happens is it won't be able to decompile it in the way it is normally supposed to be done. Okay, so it kind of misses out. So if we are able to see the an Android manifest.xml file, we see a lot of ununderstandable things that were present there, right? So let's go ahead and sort of reverse engineer it in a proper way. Okay, for this I'm just going to close this. I'm going to delete this folder. Let's move to trash. I'm going to rename this file again into diva-beta.apk. Okay, so let's use the apk. So what I'm going to do is, firstly, let's use this tool called apk tool. Okay, so let's open up the terminal. Okay, I would get into the desktop. What I'm going to do is, I see that there is a diva beta. Let me try and increase the font. Okay, I hope this is visible to you guys now. If not, let me again increase it. Okay, if I do a ls command, which basically lists all the content of this folder, which is the desktop folder here, we see that there is diva-beta.apk file. What I'm going to do is use this tool, apk tool, write an apk tool. Then it'll tell me what are all the different flags it has got. So if I use -p, it'll do a certain action. If I do -f or --force, it's going to force delete destination directory and all of that. Too much of things to sort of keep in mind. That's fine. Not for now. Probably at a
Nikhil, quick
very advanced
question.
stage, we would
Sorry,
need to
Nikhil.
sort of look at.
Can
Yeah,
you hear
yes,
me?
yes.
Sorry, I was interrupting. Um, I think maybe it was a little fast for me, but is APK tool something that we need to install, or is it pre-installed? And I know you're using a
Uh,
Mac, but a lot of us may use Windows. So how does
yes,
that,
Karthik.
can you please guide
Yes,
us?
so
Thank you.
APK tool is completely independent of the platform it is running on. So it could be installed on different set of devices, be it Mac, Windows, or Linux. So I would be sharing these set of files at the end of today's session. I'll
Okay,
be I'll be posting the link for this particular all these set of files that I'm going to be talking about today.
sure.
And the complete installation part, and getting deeper into these tools, I'll be doing it in the upcoming sessions.
Fair enough. Great. Thank you. And also,
Sure.
as you keep going, I mean,
Yeah.
I've been exposed to reverse engineering, but maybe
Yeah.
you might want to touch upon what the concept is and why we're
Okay.
trying to do that for
Okay.
this specific activity
Sure,
as
Karthik.
and when.
I'll,
All right. Just thought
yeah,
that would be easy for the audience. Thank you,
sure.
Nikhil. Thank you.
No problem. No problem. Yeah, thank you. Okay, guys. So just a small introduction about reverse engineering. So if I want to understand, how an application is built. So let's consider this diva-beta.apk file. So if I want to really understand, what are the different set of components that this application is built using, or what are all the different set of resources that this file has got, who is the creator, when did it get created, what are the different set of functionalities this application has got, and all of that. What we would usually do is we try to reverse engineer it. So from a security standpoint, when I want to sort of know more about the application's functionality, if only when I know the application's functionality is when I'll be able to sort of get more clarity on what kind of security issues I can find, right? So in the same way, what first we do is whenever we get an application is we try to get some information about this file, that's when we sort of reverse engineer this file. So one of the tools, as I was talking about, is the APK tool. Okay, so let's get started here. Let me do an ls, so we see the diva beta here. What I'm going to do is apk tool space d. Okay, so d is the flag that says decompile. Okay, and again a space, and I'm going to say diva hyphen beta dot apk file. Okay, so you can see that it is going to tell you like what are all the different set of things that it is doing at this point of time. It is saying regular manifest package, decoding file resources, decoding the values, backsmiling classes. For now this may seem a little bit advanced. That's fine, we could skip this part though. What in general, in a nutshell, let me tell you what this is exactly doing. It is basically unpacking the complete package and into its resource file, in the files that it was basically built using. Okay, so just a small intro to this. Let me just show that to you guys. So if we go to our presentation here, uh, this one slide, so this is a Java file which gets converted to a dot class file byte. This with this byte code with other files, using dex tool gets converted to .dex file, and this classes file, classes.dex file, manifest.xml file, and bunch of other resources together makes our Android APK tool. Okay, so what we are doing is we are going in the reverse direction here. Okay, so we have got our APK file. Now we are going to get our classes.dex, Android manifest.xml, and bunch of other resources. Okay, from here we are going to traverse back to getting to the dot class file. Okay, so let's do that. So what I'm gonna do is, okay, so if we look at our terminal, it says okay, so everything is done. So we get to see this here. Okay, so diva beta is ready here. So if I open this up now, and then I open up our Android manifest.xml file, let's open it up using a text editor. Okay, so you will see here like a different thing itself. It's a normal, in a normal readable XML format itself, right? So we get to see different, what are all the different activities that are there, a lot of different things. At this point of time you may get a little confused looking at this file. There is a lot of information for us to process, but that's totally fine. What I just wanted to show you is that this file can give you a lot of information about this application. Just a small intro on what kind of details it can give. So this is the user permission that it is asking. It is asking for the user permissions to write to the external storage, read into the external storage, and also for the internet permission. Okay, so in the similar way, there is something called as activity. Okay, so when we say activity, it is mainly nothing but the every single screen that you see on your application is nothing but your activity. Okay, we'll look into the activities and all of that in the in couple of minutes. Okay, for now, just remember that this is your Android manifest.xml file, and we have been able to sort of successfully decompile this to this level. Okay, so now that we have reverse engineered this, there are a lot of other different set of tools also that we get to see here. Okay, so we'll skip the apk.tool.yml file at this point of time, because this is a configuration file that is kind of specific to our apk tool. Okay, so inside the original, there is again a Android manifest.xml file. If you want to open this up, you get to see, this is the one that we had earlier got, right? This is the file that we had earlier seen. The decompilation part that didn't really happen in the right way, right? So now if I go to res folders, it will have all the resource files that are very specific to this particular application, something like your icons or your logos or any cursor kind of a thing. Anything that is specific to that application is inside this resource folder. Okay, so under the original folder, we also get to see another folder here. Okay, so let me write it down so that you guys don't get confused here. Let me open the so uh, we reverse engineered apk2, right? The command for this was apktool space d space the file.apk, right? So one thing we need to remember here is here d means decompile. Okay, so d is something that we need to use here. Let me sort of highlight this or sort of, okay, so that's one thing. uh, then what we did next, so the file structure. So if you look at the file structure here inside the Diva beta, let me put this up somewhere where we have our things also ready to write. So in the file structure we have Android manifest.xml. Okay, then we have our library folder, lib folder, then we have our original folder, then we have our res folder. So we are going to skip this part, the Smalley and the APK tool for now. Okay, we could go on and write it though. Smalley folder and the apk tool.yaml file. Okay, so under the original folder, we again had something called Android manifest, which is an older one, older android.xml, android manifest.xml file. Then we have our meta-inf folder. Okay, so if we closely go ahead and look into this, there are three different files that we get to see. Okay, so let's kind of give some numberings to these or put them in the bullet points so that it becomes a lot more easier for us. So we have cert.rsa, and then we have something called cert.sf, then we have something called manifest.mf. Okay, so just a small intro on what these different set of files are. Okay, so the cert.rsa will give you information about the developer who has written this application, and a complete details on when till when is that certificate valid, and let's say if a certificate gets expired, so it loses its presence on the on the App Store. Okay, so the Android Play Store would sort of certainly remove the application off the Play Store. Okay, then there is something called cert.sf and manifest.mf. So these two files are very similar. So what these contain are nothing but the list of all the resource files. Okay, so let me just open this up and show it to you guys. So I could open this up using a basic text editor. So you get to see that name. There are two parameters that is given here, which is the name, and there is SHA1 digest. Okay, nothing much to worry if you guys are not able to understand what is this file all about. So in the simple terms, it is mainly to check the integrity of all the files that are present in this package. Okay, so integrity as in, let's say if I as an attacker kind of reverses this file and adds a malicious file into it and repackages it, the Android mobile should be able to easily detect that, hey, there is a malicious application that someone has put in. Okay, so for now, don't really worry much about what's really happening here. Okay, we'll come back to this again. So let's get to our emulator here. Okay, so in our emulator, we see that we have installed the Diva beta. Okay, so let's open this up. So this emulator is nothing but fairly very similar to our normal mobile cell phone, Android cell phone. Okay, so these are different set of security issues that are usually found in mobile applications. Okay, we'll look into that. So there is something called as insecure logging. So this application is very specific for you guys to sort of go ahead and try out or test your different set of vulnerabilities that you want to find on a mobile application. Okay, so there is something called insecure logging, hard coding issues, part one, insecure data storage, and bunch of other things. Okay, so what is this application? The main functionalities of this application is for you guys to go ahead and sort of test all your security learning on this application. Okay, so let's say we look into something called as insecure data storage. Okay, so it says that what is the objective and what is the hint here. The objective here is to find out where and how the credentials are being stored and the vulnerable code. Okay, and the hint is that insecure data storage is the result of storing confidential information insecurely on the system, which is poor encryption, plain text, access control issues, etc. So more on this, we'll look into that. So for now, let's type in some important details like Nikhil, and I'm gonna write again same thing, Nikhil 12345, and I'm gonna save it here. Okay, third-party credentials are saved successfully. So if you could remember from yesterday's session, what we also did was we were able to use something called as ADB, right? So let me clear this. So if you guys remember ADB, I'm sure you guys would remember if I am able to sort of type in the commands. So if I do ADB space devices, so this ADB is nothing but Android debug bridge, and the devices command would list all the devices, as in the mobile devices that are connected to my current, my current system. Okay, so for now, this is the only device that is connected, and this is running on port number 5555. Okay, that's fine. So what we are going to do is we are going to get into this particular device using our command prompt, which is terminal. So what I'm going to do is simply ADB space shell. Okay, so this gives me access into this particular device. Okay, so if you could remember from yesterday's session, what I did was if I could just do a ls command, which is a list command in Linux, since we all know that from yesterday's session again that uh, you know Android is basically is based on Linux kernel. Okay, so this would give us a complete file structure, a file system structure of the this particular device. Okay, so for now our main focus is to only focus on this particular application, which is Diva. Okay, so we are going to get into the resource folder of this particular app. So we're going to get into cd, which is change directory data/data. So always remember that all the application specific data is present in this particular folder, which is data/data. Okay, so we'll do this. Now we do a list, again ls commands. we see that there are a lot of different set of applications that are already present here. Okay, so there is contacts, there is Chrome, camera, but for us it is the Diva that we are looking at. So for Diva, here we have, so it says jacker.asim.diva. Okay, so let's get into this folder as well. Okay, so we do cd space, okay, jacker.asim.diva. So now we are into this folder. Let me clear the screen, and I do a list command, ls again. So I see a lot of different set of folders, files, and all of that. Okay, so what I'm gonna do is let me get into any of the files here. So let's get into shared preferences and see what could be done. So I do shared preferences, I do an ls. So when I do an ls here, again I see there is an XML file. So XML file, since we all know, is easily editable, or you could easily read it using the normal text editor. So I'm going to just use cat space the file name. Okay, so if I do that, so I see that password and user to be Nikhil12345 and Nikhil12345. Whatever I had stored here gets stored locally on the device in this place. Okay, and this should not be the way how things usually get stored. Okay, so here we saw that it's an insecure way of storing the data, wherein you see even your password is being stored in the plain text format. Okay, which is totally a wrong implementation of secure way of storing. Okay, so the first place where we found a security issue, okay, so let's write it down here. Okay, uh, insecure data storage. So the first place that we found was in shared preferences. Shared preferences folder, under which it had an XML file, and that basically had our data, which is the username and the password here. Okay, so one thing we also need to look at is encryption. Okay, so since we were able to sort of reverse engineer this into diva-beta folder, and we were able to get a lot of data, the reverse engineered data, we would be also using another tool here. I hope you guys, I know it's all clear for you guys at this point of time. If not, just let me know. I'll sort of be able to sort of take any questions now, or you could sort of send me your questions later at the later stage as well. Okay, so let's get going. So now let's use our tool called as dex2jar. Okay, so this tool is basically to convert either your APK files into jar files, or your your dex files into jar files. Okay, so if you could remember, we found a dex file somewhere here. If we're not able to find it anywhere here, right, we could be able to easily go ahead and sort of use the APK file itself and convert it. Okay, so what I'm gonna do here is, again, I'm gonna open up the terminal. So let me clear this, let me exit from here. Okay, so I do an ls. So what I'm going to do is run this command day2j hyphen dex2jar. If I do this, it will basically run this particular tool d2j hyphen dex2jar, and it will show me what are all the different set of flag it offers. Okay, for now we do not have to really worry much about these different set of flags, but let's go ahead and type in our main command, which is dex2jar space the file that we are currently trying to look at. So this is the file that we want to convert, right? So let's wait for some time for it to get converted. So seems like it just got converted. Okay, so it means that there is a jar file that we see here that it just produced. So what I'm going to do is open this jar file using a tool called as JDGUI or JDGUI. Okay, so this JDGUI tool will allow me to open any jar file. So what I'm going to do is uh, open this up right here. Okay, so if you closely look at this, it's sort of given me the dot class files directly. It's given me access to its code base itself. I've been able to sort of reverse it completely. And if you look at our insecure data storage, part of the code, it kind of shows us the shared that things are happening at the shared preferences, because it's opening the shared preferences dot editor, and there is preference manager, get default shared preferences and all of that. Okay, so this is happening at the shared preferences level. And let's look at what has the insecure data storage 2 activity has got, how exactly it is kind of storing it in an insecure way. Okay, so if I look at this thing here, I fairly kind of get a feeling that it is trying to sort of create a table if it does not exist, with my user table, and what are the different set of parameters it is giving. So I kind of get a feeling, okay, it also says insert into my user values. So which means that, okay, so if you could see here, it says execute SQL. So it is executing SQL queries. So what does it mean? So it means that it is kind of, it is basically trying to store the data in the database. Okay. And let's see if it is storing the data in an insecure way. Okay. So what I'm again going to do is open this up. I go back, which is the insecure data storage part 2. Okay, so I'm again going to enter a similar things, Nikhil 67890. So in the similar way, I'm going to write 67890 here. Then I'm going to save it. It says third-party credentials have been saved successfully. In my terminal, what I will do is, let me clear the screen off. I'll again do the adb space shell command and get a shell access into this. So I'm going to do again a cd space data slash data. Okay, I get into the same folder, which is jacker.asim.diva. Let's do that. Let me clear this off, and I do again a list command. I really hope I'm not going really fast. Let me again do a list. So here again we see different sort of files and folders, but the thing that is that interests us at this point of time is databases, because we know from the backend of from the reverse engineered code that where the data would basically be getting stored, right? So I'm going to do a cd slash into databases. I'll do an ls. Okay, so there are different set of database and .db .db journal files and .db files. Okay, so we need to sort of go ahead and look into these different set of files. Okay, so how we do that, let's go to another new tab. I'm going to open up a new tab here, and let me get into my desktop. Okay, so since I'm already in my desktop, okay, what I'm going to do is, again, I'm going to use the adb command. I'm going to do the adb space pull space. So this is the file that we are looking for. The databases folder. Okay, I'm just going to copy this. So I'm going to type in adb space pull space the command here. So this will pull out that particular databases folder onto my actual device. So we have the databases folder here. Okay, but before that, let's just write down whatever we have done so far. Okay, so second one we think would be in the databases. Let's keep it aside. Okay, considering the tools part of it, the second one that we used is the Dex2 jar. Okay, so this is mainly to converting the .dex or .apk files to .jar file. The command for this is d2j-dex to jar space the file name, the file.apk. Okay, so if we do that, okay, so this is something that is needed. Okay, so this is a command, and once we get the .jar file, we open it using the JDGUI or JDGUI tool. Okay, so as I had mentioned, these are the three major tools that we basically use here. Okay, so since we had gotten the complete source code using the JDGUI tool, okay, so we found that the first one was basically the shared preferences. The second one had to be the database. Now since that we have already got the database folder, let's see if we get some idea where things are getting stored. Okay, so there's one more tool I'm going to be adding here for now. This is an optional tool. This is the SQLite DB browser. It's an again open source and freely it's a freely available tool, that you could just go ahead and download it from the internet. But for all these tools, I'll be sort of giving it to you guys at the end of this session. Okay, so this is one thing. So let me open this SQLite DB browser. Okay, so let me open up the database in the desktop. We have the database, we have SQLite. Let's see if what no, it was not here. Let me open up IDS2 database structure. No, open it here. Is it in this? Okay, so I think it must be in IDS2, but the data is in the my user. Okay, so these are a bunch of other random data that I had used previously today. This is something that we had given quite recently, right? Which is Nikhil 67890 and Nikhil 67890. And again, if we could see here, the username and the password are being stored in the plain text. Okay, so usually, when you store the username and password in the plain text, it usually gets gets a lot more easier for the attacker to compromise it. So the best ways for the developer to store these data in a secure manner, first thing, they should never be storing the passwords in the database files like this. But if they ever want to store it, they need to ensure that it is hashed. you know Hash is something, it's a cryptographic function. We'll look into that, the hashing format and all of that in the couple of upcoming sessions. For now, let's just understand that the second one that we looked at was basically a database uh, folder. Okay, so we had it in the IDS, if I'm not wrong, it was IDS2. Okay, so in the similar way, let's also look at the third one. So the third one is insecure data storage, but we could also right now look into uh, the JD GUI. If you look at this, insecure data storage, okay, the file writer, it is kind of telling us that it is storing the data in some certain set of files. Okay, uinfo temp. Okay, so it means that a file is getting created in the name uinfo temp. Okay, so what I will do is, let's go to the terminal. Let me clear this. Let me open up a fresh instance of terminal. Okay, so let me get into the desktop. I'm going to do an adb shell into this again. Okay, so cd/data/data. Okay, again cd into, again let's do an ls first, jacker.asim.diva, right? So we'll do jacker.asim.diva. Let me clear this again. Let me do a list again. So we have bunch of temp files which may confuse us at this point of time. So let's kind of remove that if it's possible. Okay, I do an ls here. Okay, so all those temp files are gone. So what I'm gonna do here is, let me type in a file, let me type in like Nikhil 123456780. Okay, and I'm gonna save this. So it again says third-party credentials have been saved successfully. Again, if I do an ls, so if you just noticed here, there is a file that gets created. Let me clear this for you. Okay, so it says uinfo hyphen 6577 some random number temp. Okay, which means that the file is kind of getting stored in the temp file. Okay, so let's look into that and see what we get. So I'm just basically going to use this cat. So cat command would be used to sort of look into what are the contents of that particular file. So I will use this, and again we see that the username and the password is being stored in this particular temp file in the very plain text format. Okay, so this were like the three primary ways the data gets stored in an insecure manner. Okay, and on the Android applications there are a lot of different ways the insecure data can be stored on an application. Okay, we look into that in couple of minutes as well. Okay, so the third one here was a temporary file. Okay, so it was if you could just look at this, it was something like uinfo temp file or something, right? So let's write it down, uinfo temporary file. Okay, so these are the three major places where we were able to find insecure data storage. Okay, let's get back. So before we get into the fourth part of the insecure data storage, we'll actually look into the second part of it. So that we could do here is, I am going to leave for to you guys to find out, where it's stored and all of that. That's like a homework for you guys. I want you guys to go ahead and download this application, which is Diva. If not, you could just Google it, say diva-beta.apk or just Diva application. You would be able to sort of get the download link and download it, install it on your actual device or on your emulator like this. It's fairly easy. I can assure you that this is not a application that would harm your mobile device for sure. You could just install it, no problem. And I would want you guys to sort of go ahead and try this, try the fourth one, insecure data storage part 4. Okay, and you guys could come back to me tomorrow and let me know, where did you find the fourth one. Okay, so I'm moving to another one, which is the hard coding issues. So hard coding, when they say it, hard coding is nothing but saving a certain secret or critical data on the in the application's code base. Okay, so something like passwords or some sort of credentials or some keys or API keys should never be sort of hard coded in the application. When I say hard coding, it means that when you look at the code base here, let's go back to the code base. Okay, so this is the code base. If it gets written somewhere here, like like this is a certain password or something, then that's called hard coding into the application. Okay, so let's not look into this hard code activity before we do this exercise. They say that our objective is find out what is hard coded and where. Hint, developers sometimes will hard code sensitive information for their ease of use. Okay, so enter the vendor key. I randomly enter something. It says access denied. Okay, so I ran then again I gave it a shot. Try entering how many ever passwords I want. It's vendor keys I want. It is not letting me go in. Okay, it's not giving me any access. So what I do is, as I've already reverse engineered the application, right? So let me look into the hardcode activity class. Okay, so I know this is fairly easy when we sort of reverse engineer it, right? So it says toast.makeText, this access denied, see you in hell, if you enter the wrong password. But it says for a particular key, it kind of gives the access granted. It says access granted, see you on the other side. But for which? But if you actually read this code correctly, so it says if it equals to this string vendor secret key, okay, it is allowing us to sort of go ahead and get into that. So let me give it a shot. I've just copied it here. Let me paste it. Does it allow me to paste? Yes. Okay. Let me, okay. When I do that, it says access granted. See you on the other side. Okay. So this is one way of also sort of in wrong implementation. Okay, because when you are able to sort of store something like this on a particular application hard coded, then it becomes a lot more easier for the attackers to sort of just run through the code and sort of get access to those kind of keys. Okay, so just kind of brushing up about what we have done so far. Let me open up the uh, Chrome browser. Okay, so we looked at these different four set of tools. Okay, so we have just touched upon the basic stuff here, wherein we used APK tool to sort of reverse engineer it. We used the decompile flag to sort of decompile the application. We got a really good file structure, which is the Android manifest.xml file. Then we got hold of the lib folder. Then we had something called original folder that also had the older Android manifest.xml file. Then we also had something called meta-inf, which had certain things like ser.rsa, ser.sf, manifest.mf, and these set of files. Then we also had the resource folder, the Smalley folder, APK tool. So as we also discussed, we are going to look into these different these folders and files at a later stage. Okay. After we were done with that, we also used dex to jar. So this allows us to convert either the .dex files or .apk files to .jar files. Okay, so the command that we used here was d2j-dex to jar space file.apk. Okay, so once we get the .jar file, we open it using the JDGUI tool. Okay, then we were able to find these major insecure ways of data storage on this application. Okay, so what I would suggest you guys is your homework is to go ahead and try the fourth one. Okay, the fourth one also has a pretty similar one. Find out where or how the credentials are being stored and the vulnerable code. Insecure data storage is a result of storing confidential information securely and all of that. Okay, so let's say I'm going to type in some random data here. It again gives me the same kind of toast saying that the data has been saved successfully. Now it's your job to go ahead and try this out, the same thing, and let me know tomorrow or in the next session that where you were able to find it. Okay, so we'll also be looking at the other bunch of vulnerabilities, and these are not the only vulnerabilities that will be able to find. There are a lot more vulnerabilities that we'll be looking into. Okay, so in the upcoming sessions we'll be working with multiple other different sort of applications. So this is just one application that we looked at, which is the Diva. There are a lot more applications that we have developed. Okay, so the Diva is again not developed by us. It's already readily available on the internet. But other than this, we also have developed a bunch of specific applications that you could go ahead and try on. Okay, so one thing that I want you guys to remember here is that most people usually sort of tend to miss is just a second. Let me put this up in a proper way. Uh, Remember, okay, the application specific resources and data is stored in /data/data folders. Okay, so we got to remember that that's the place where the data of any specific application gets stored. Okay, I think this file I will be sharing with you all. Okay, other than this, I'll also share the links to download these set of applications. Okay, so these again you would get it on the internet, but I've also sort of made different folders and sort of added all these files specific to your operating system that you could install. Okay, so I think that was it from my side for today's training. If you guys have got any sort of questions or any doubts or something, you could go on and surely ask it right now, or you could sort of send us out a mail and we'll be happy to sort of help you guys out. So I'm just looking at the questions. If someone's put in any question or something. I really hope the session that we had today was informative and has kind of given you like a brief idea about how security issues are found and how they exist and how we could be able to sort of exploit. So whatever we did today is like a complete basic understanding, a basic security flaws that we were able to find. There are much more advanced level vulnerabilities that exist that we would be looking at in the upcoming classes. Okay, so I think we are done here. I think Karthik, if you're
Yes,
around,
I'm there.
yeah, Karthik.
I did step out for a couple of calls in between, but thank you, Nikhil. I think we're going into the depths and very nicely how we are doing. One quick question I had. So it's the same concept even with any other reverse engineering of any other applications, right? Like a Java
Yes, yes,
application and so on, different tools for it and so on.
exactly.
And
Yes,
that is
yes.
where the risk comes of, right, from source code all the way to finding loopholes to break the security.
Exactly. Yes, Karthik.
Correct. Yeah, that's pretty much what I could gauge with. That's great. Thank you, Nikhil. I think we'll then we're all set for today. We'll see you back tomorrow. We're
Sure.
organizing everything in the Google Drive. We will not be
Yeah,
able to share any links or documents yet. Maybe after day 3 or day 4, we will be
exactly.
putting it in the membership area, Nikhil. All right.
Yes,
So
yes, Karthik.
let's keep them in our Google Drive for now. All right.
Sure. Sure, Karthik.
All
Okay.
right.
Thank you,
Great.
everyone.
Thank you,
Yeah.
everyone. Thanks, Nikhil. Bye.
Bye.